Hi there, welcome to this video. We are going to solve some trigonometric equations that have quadratic structure, meaning you're going to see sine squared, cosine squared, tangent squared, etc. Okay, so this will really follow kind of what we did in the first lesson, so check out that video if you haven't not yet. All right, lesson 2, trigonometric equations with a quadratic structure. We're learning to solve these, and in order to be successful, you got to know your sine and cosine values of a unit circle or have that information handy to you. No pun intended, because if you know your sine and cosine values are on your left hand, at least for quadrant 1, and you can solve quadratic equations by factoring or by using the square root property, right? Ax squared plus bx plus c, you can factor that down into two linear factors and then solve those. Or just by taking a square root, you get a plus and a minus option. And then you can be successful if you can use trig identities to rewrite a trig function in terms of sine or cosine, okay? So, prior knowledge, make sure you remember that the zero product property says if you have two things multiplying equals 0, then A equals 0 or B equals 0. And mainly we're going to be using this when we break down a quadratic, something like this, like AX plus K times bx plus c. If this equals 0, then I can set each of these equal to 0. And then the square root property, if you have a value squared equals a number, then when you solve, you take a square root, you get a plus and a minus option, okay? So don't forget those. Also, prior knowledge, you want to know your identities, mainly the reciprocal identities. Know that cosecant is the reciprocal of sine, and vice versa. Secant is with cosine, and cotangent is with tangent. As well as knowing that tangent and cotangent in terms of sine and cosine, because really, when we're solving, we're going to put everything in terms of sine and cosine, so we can use unit circle to help us solve. So remember these two identities. Okay, so quadratic equation. How do we go ahead and solve this? So this is an example of what a quadratic structure would look like. Sine squared x minus 1 equals 0, or vice versa. You know, I have two trig functions multiplying. You're going to go ahead and write the equation in standard form. So something looks like this: ax squared plus bx plus c equals 0. Number 2, you could use a quadratic strategy where you take a square root or factor to kind of break this down, and then you're just going to solve those equations and find the angle measures. Now remember, sometimes for AP Precalculus, you get a question that says solve or give all solutions. That means that we have to go ahead and add 2 pi k. We have to add extra revolutions, right? Because the angles, if I went around the unit circle another time, or even in the negative direction, all those angles would be possible solutions as well. Same for secant and cosecant, because the period is the same since those are the reciprocal functions of sine and cosine. Tangent and cotangent, we add plus pi k, because the period on those is just 1 pi. Okay, enough yapping. Let's look at some examples. Example 1, the function g is given by g of x equals 3 tan squared x minus 1. Find all values of x for which g of x equals 0. So I'm going to go ahead and I'm going to take my function 3 tan squared of x minus 1, and I'm going to set this equal to 0. That's what they want. Now this is a quadratic structure, and rather than go ahead and factor, I mean, there's nothing really to factor this. It's not like a ax squared plus bx plus a constant. So I'm just going to move my terms over. I'm going to undo addition, subtraction. First, we get 3 tan squared x equals 1. And then I'm going to divide by 3. And so what I'm doing here is I'm isolating my trig function, and it's equal to 1/3. And this might look weird. You're like, what the heck? How do I do this? Well, I'm going to go ahead and I'm going to take a square root. I'm going to take a square root here. And what this gives me is it gives me tangent of x is equal to plus or minus the square root of 1 over 3, which is plus or minus the square root of 1 over the square root of 3. Now, this doesn't really look familiar, but if I go ahead and simplify the numerator, obviously, and then rationalize, this will look familiar. What if I multiply both by square root of 3 over square root of 3? And all of a sudden, I get the value plus or minus the square root of 3 divided by 3. And that should seem familiar. Those trig values should seem familiar. Now there's two ways to really go ahead and solve this. One way is to say, hey, I know that sine of x over cosine of x, that's tangent. So this is equal to the square root of 3 over 3. And you can kind of do some trial and error to figure out, okay, is this 1/2 on top? Is this square root of 3 on top, right? And so this actually would be equal to, if you had 1/2 on top and square root of 3 over 2, because this is 1/2 times 2 over root 3, gives you this 1 over root 3, right? And so this angle here is your pi 6 angle, pi 6. I'll get to the plus and minus here in a moment. You should have plus minus on all of this, okay? So I think there's an easier way, and my approach to this is just memorizing. I know you're like, oh, memorizing. It's really easy, is y equals tangent of x, okay? And tangent of x has some core values, right? So at angle 0, if theta is equal to 0, you get 0. And the other easy one, pi fourths. What if my x value here is pi fourths? I know that my sine and cosine values are the same, so that output value is 1, right? Those are key points if you learn to graph this. Well, I have the other values that both have a square root of 3 in them, okay? And one of them is divided by 3, and that's going to be a smaller value, right? So that is this value here, because the square root of 3 divided by 3, right, is smaller than the square root of 3. This is the square root of 3, and that right there is the square root of 3 divided by 3. And so how do I remember this? Well, tangent's an increasing function. So a lower value is going to have your smaller angle, your pi 6. So if you're a smaller angle, which this one is, you get the smaller value. It's going to be pi 6. If it was just square root of 3 for tangent, then you would be the bigger angle, pi thirds. Okay? So note that this is plus and minus. So my positive values, where is tangent positive? That's going to be in quadrant 1 and quadrant 3. Okay, so pi 6, 7 pi 6. And where is it negative? Well, this also occurs at angle of 5 pi 6 and 11 pi over 6. Okay, so use your unit circle if you need help finding those values. Okay, so these are all the angles for 0 to 2 pi, but this question's not asking that. Why did you make me write that? Well, I wanted to introduce that. They say here find all values. Find all values. So pretty easy here. Our answer is going to be theta is equal to, I have pi 6, okay, plus pi k, as well as, so that's my positive answer, and then I have 5 pi 6 plus pi k, where k is an integer. Right, and that's mathematical notation for k is an integer. You can also write k as an integer. So two possible solutions here. If they said on 0 to 2 pi, you would have these 4 angles. Okay, hopefully that makes kind of some sense here. All right, here is a practice one. This one should not be as difficult. I want you to go ahead, pause me. I want you to try this one, and then I'll show you the solution here to this practice one. Go ahead, pause me, try this one. Okay, here they want f of x, which is 4 sine squared x, to be equal to 3. So we can go ahead and set them equal, and then we're going to isolate our trig function. So I divide both sides by 4 here, and then we have sine squared. So I'm going to take a square root of both sides, and that gives me the square root of 3 over the square root of 4. And hopefully this is, sharpening your memory of this value, plus minus square root of 3 over 2. So we just have to go ahead and remember, where's my y value, square root of 3 over 2. If you forgot, look at your left hand. I want my y values, which are the second values, to have a numerator of 3. So I'm going to put down this finger, which corresponds to my pi thirds angle. So we have here x is equal to pi thirds, okay, plus 2 pi k, plus 2 pi k. And we also have, so that's a positive value. The other positive angle for sine is going to be in quadrant 2. So we have 2 pi thirds, 2 pi thirds. Oh my gosh. here we go, 2 pi thirds plus 2 pi k. And we also have where sine is negative. This is going to be in quadrant 3, 4 pi thirds plus 2 pi k. And the last one we have is 5 pi thirds. This is quadrant 4 plus 2 pi k. And then for all this, I'm going to say where k is an integer, an element of the integer, okay? So, there you go. There you go. Some of these are repeating. I mean, you could go ahead and kind of consolidate this, but there you go. Those are your angles plus 2 pi k. All right, next example. This example says the function f is given by f of x equals 2 sine x cosine x, and the function g is given by g of x equals negative cosine x. Find all values of x for pi to 3 pi over 2 in which f of x equals g of x. So what I'm going to do here is I'm going to set my function, the functions equal to each other, right? They want to know where is f equal to g. And so I have 2 sine x cosine x equals negative cosine x. And I'm going to add this over. I'm going to set this equal to 0. So I'll add cosine x over here. And this can be tricky because you need to know that these do not combine. These are not like terms. This one has a sine x cosine x. And so I'm just going to add a cosine x here. And this is equal to 0. And so at this stage, this is going to bring up a kind of a new strategy that I'm going to go ahead and teach you. If my pen lets me write, which it's not right now. Okay, there we go. And so here's the new strategy. Do you guys see how these elements are the same, right? Cosine x. Right, this is the same as having a kind of like a like term. I can't combine them; they're not like terms, but they have the same factor, I guess I should say. So what I'm going to do is I'm going to factor this out. I'm going to take out a GCF. This is a GCF of cosine x, and what's left over is 2 sine x. Right here, I lose a cosine x. This cosine x cancels, and I divide by cosine x here, and so cosine x divided by cosine x is 1. So I get this, equals 0. Okay, so this is a GCF factoring type problem. And now I can go ahead and solve these separately. So what we get from one equation is cosine of x equal to 0. And we also get equation number 2. Down here, we get 2 sine x plus 1 equals 0. So we solve both of these. Where does cosine of x equal to 0? Well, this is pretty straightforward. This is the North Pole and the South Pole. And here they don't want all solutions. They don't want all solutions. They say between pi and 3 pi over 2. So guess what? This answer right here, we're going to throw that one out. And then we can go over here and solve this one. So subtract 1. We have 2 sine x equals negative 1. We'll divide both sides by 2. And we get sine of x equals negative 1/2. Okay, so where does sine of x equal negative 1/2? Again, I'm going to use my left hand. I want my y values to be 1, and that's going to be pi 6. So this is going to occur at x equals, not pi 6, because that would be positive. We want negative angles. So that's going to be 7 pi over 6 and 11 pi over 6. And again, they only want really quadrant 3, from pi to 3 pi halves. So we're going to throw away that answer. Okay, so 2 possible solutions. Okay, let's go ahead and look at the next practice question. Here they want to know the function g is given by g of x equals sine squared of x. The function h is given by h of x equals sine of x. Find all values of x for 0 to 2 pi for which g equals h. So go ahead, pause me, please try this one, and we'll talk through the answers. Okay, in this example, we went ahead and set the two functions equal to each other. This sine of x, again, this is a quadratic structure, so I'm going to move everything over to one side. So I'm going to subtract this sine of x. And again, I cannot combine them. They're not like terms, because this would be like something like, over here, I'll just give you an example. What if it was x squared is equal to x? Something like this. So I'm going to subtract this over, and we're going to do, again, a GCF. So notice what I do here is we factor out a GCF, and we get sine of x times sine of x minus 1 equals 0, and we get two possible solutions. Sine of x equals 0, well, that happens at two locations. Angle 0, not 2 pi. Notice how the domain given does not include 2 pi, so it's just angle 0 and angle pi. And then sine of x minus 1 equals 0. That's where sine of x equals 1. That is angle pi halves at the top of the unit circle, okay? All right, so hopefully you got that right. Let's go ahead and look at our last example. Here it says find all values of theta on the interval 0 to 2 pi for which sine squared of theta plus sine of theta equals 2. So again, I have a quadratic structure here, sine squared theta plus sine theta equals 2. And what I'm going to do is I'm going to move this 2 over to the other side. I'm going to subtract 2. Okay, so this cancels, and now I have a statement that looks like this. Sine squared theta plus sine theta minus 2 is equal to 0. And what I kind of want you to see is the structure x squared plus x minus 2 equals 0. Because we're going to go ahead and we're going to factor this like it was a normal quadratic. So I'm going to split my sine squared term, right? This gives me sine theta times sine theta, and then I'm going to split 2. And that's going to be a 2 and a 1, and I need a negative 1 with a positive 2. That should do it. Okay? So again, we get two possible solutions. I have sine theta is, sine theta plus 2 is equal to 0, and sine theta minus 1 is equal to 0. Now, this first one, when I go ahead and I subtract 2 over to the other side, I get sine theta equals negative 2. This never happens. This is not possible. So you're not going to have a solution here for this statement, but over here you will, right? Sine of theta minus 1 equals 0. That means sine theta is equal to 1. And we go ahead and solve this, and we kind of just did this one. You get pi over 2. Now they do say all values of theta, so again, I have to add 2 pi k, where k is an integer. All right? Cool beans. Okay, here's the last practice one. Please go ahead, pause me now and try this practice. I'll show you the solutions. Okay, hopefully you got this solution. The first thing you have to do is go ahead and move this 3 over to the other side. So we subtract 3 on each side, and we get 2 cosine squared theta minus cosine theta minus 3 is equal to 0. And we can go ahead and factor this. So I split 2 cosine squared theta, 2 cosine theta times cosine theta, and then thankfully I have a prime number over here, so not too many options. It's 3 and 1, and you kind of just gotta guess and check, right? So I'm gonna pair the 3, so that way I get a negative 3 cosine theta, and then the 2 with the 1 to give me a positive 2, which those together give me a negative 1 cosine theta here. So two possible outcomes, 2 cosine theta minus 3 equals 0, or cosine theta plus 1 equals 0, and we just solve. Add the 3 here, add the 3, divide by 2, all right, and you get cosine theta equals 3 halves. That's 1.5, and that's outside of the range. There's no x value that's 1.5 in the unit circle. So this one's not possible. We're just going to go ahead, cross that out. And then over here, cosine theta plus 1 equals 0. Well, that means cosine theta is negative 1, and that only happens at the angle pi, plus infinite revolutions, forward and backward. So we have to add on the plus 2 pi k, because this one says all values of theta. Okay? Hopefully in this video you learned how to solve quadratic structured trigonometric equations, things that have like cosine squared, sine squared, and even tangent squared theta. Okay? Make sure you're comfortable factoring a trinomial like this, and if you get scared, just remember, what if it was 2x squared minus x minus 3? That'll help you kind of break it down. You could take out a GCF, right? Or you could just take a square root of both sides. Okay, so that's kind of what we covered. Give the video a thumbs up if you learned something. I'll see you in the next video.